Here's a simple one. All right. This is great. We'll start with simple as I collate the other ones. Very simple question, which is, what is the best water to drink?
Suffolk County Water Authority.
That was definitely a plant.
Okay. Here's one specifically. Let's see. It says, for the organic media you're developing, noted that the life cycle cost is less than the cost for GAC. One of the biggest concerns with PFAS treatment is the downtime. How does the time to exhaustion of the media compare to coal-based GAC? And can this be reactivated, or is it single use?
Yes, so I think I will take that one. So we have to realize that the project we are in, the Charlie, as I mentioned, CHAR for Long Island's environment, we are pretty much at the initial stage. So we have been on this project for the last 6 months. We have done a lot of testing in the lab on the bench scale setup. We have a really good partner who looks at life cycle analysis, which is basically going to be over the next 1.5 years, where we are going to do the life cycle analysis for all the aspects of sustainability, including the fouling and the end-of-life solution. But that information is forthcoming. So we still are, again, highlighting that at first 6 months. So I think I would probably be in a better situation to answer that question in the next symposium.
Okay, this is a very site-specific question, and but I think applies to other places. So the specific point is about Southold water, and that it's contaminated. And what's the condition of the water for the residents, and what actions are being taken? In this case, it's by the U.S. Navy, but I think it's an even broader case that some people hear that their water is contaminated, and what are they supposed to do? And I think. Yeah, maybe you have a quick comment, and then, because of course, importantly, not everybody has public water, right? Some people have private wells, and not all public water comes from the Water Authority, and I'm not sure the case in Southold, but.
Yeah, I'm not sure exactly. You're talking about Navy contamination. To me, that's the contamination in the Calverton area, that's Riverhead, not Southold. In Southold in general, I can speak to issues with the groundwater there, or similar to what you see on the South Fork. So chlorides are an issue. Pesticides that we treat for with using GAC, and of course PFAS.
Okay, here's a question. Specifically, wanted to know what you're doing about microplastics. So, okay, yeah. So, Lokesh, maybe you can explain what we are doing about microplastics emerging.
So I think very timely question, and Scott is here. Scott just recently approved the new work plan. So till now, we have been focusing on PFAS because that's what was consistent with our annual work plan in collaboration with New York State Department of Health. But in the new plan, which starts from 1st of August, we actually have included microplastics for 2 reasons. First of all, there is a lot of literature now that's coming through that clearly shows that microplastics, and particularly nanoplastics, are a huge concern. And the second is that we recently acquired analytical capability, which is GCMS pyrolyzer, where we can measure the microplastics. So we are starting the projects. The plasma treatment project that you saw is going to include PFAS and microplastics both, and we are slowly going to expand from there and do all these treatments, evaluations for the microplastics as well. So again, for the next symposium, hopefully we'll have some really good results along with PFAS for microplastics.
Okay, now a question specifically for Tim, and that is about the ion exchange resins. And the question is, what does the waste handling of used ion exchange resin look like, and where does it go?
Yeah, so the Water Authority uses a single-use resin, and at the end of its life with us, it's taken, and part of our specifications is that we have to have a chain of custody to show that it's been properly disposed of, which for the single-use resins, it's incineration so that the PFAS is destroyed.
Yeah, we have some similar type questions here. I have 2 in front of me. They're about the same, but I'll say the first one, and then I'll hit the second one, and then. But the first one is with regard to the PFAS: is it eradicated or transformed? And then along the similar lines is a question about with the PFAS compounds, are they getting turned into compounds that are not regulated or less studied? So I guess the idea of treating, as you treat them, are the compounds transforming, or what's happening on that front?
Yeah, so I think the two treatment approaches I highlighted in the presentation, one was separation with the biochar, with the electrocoagulation, and with the MIPS that you saw. And that basically just takes the PFAS from the water and puts it on the solid phase, right? But in terms of destruction processes I described, our goal is to have defluorination, which means that converting PFAS to harmless fluoride. And as you can see on those electrochemical oxidation or vacuum UV processes, our aim is to go as close to 100%. So yes, currently oxidation, we have 90% defluorination, which means 90% of the PFAS has been converted to fluoride, which is harmless, but that remaining 10% is probably some of the intermediate PFAS, which may not be regulated. So our aim is to make that close to 100%.
Okay, I have two questions here that are almost identical. They're both about what's the best at-home water treatment, specifically for short-chain compounds. And in some cases, they're saying, is there anything besides reverse osmosis? So home treatment of water for contaminants in general, for short-chain PFAS in general, and is there anything beyond reverse osmosis? Who wants to take that one?
Scott, you want to make
Scott, want to take them? There is information available on our website about, our message is always it's always a reduction of exposure message. I know carbon filters will still do something for short chain, and again, it depends on what you call a short chain. These days, it's kind of changing. I know from an industrial standpoint, obviously breakthrough, if we're talking about breakthrough, would be quicker for short chain compounds, but that's not really the environment that you're working in at home. So I would go ahead and ask folks to make themselves or avail themselves of the information we have available online. I think that gives some good direction about what to look for when shopping for available treatment.
Okay, Scott, don't turn off that microphone. Here's another one. Specifically about DOH and mandates and regulations. And specifically, are those mandates based on treatments already available? And so is it the treatment, is it the technology that dictates the levels that are set?
Well, so when you set a level, there's a statute that you have to follow, and one of the components of that statute, you have to be able to identify a best available treatment technology. So the short answer is yes. That's clearly a component when setting an MCL, when setting a standard level.
Okay. Question here about pH and PFAS, and I guess it's the question, I guess, overall here is how does the pH of the water, does that affect the PFAS specifically? I know, Lokesh, you hit on that a little bit, but, and also it's specifically asking about the chain length of the PFAS. Is that affected at all by pH?
Yeah, I think so. It pretty much depends on the treatment we are talking about, right? Because I think if you remember the slides on fouling of the GAC, what our research shows, which is led by Dr. Philip Wong, is that if you have an acidic pH, the dissolved organic matter becomes a lot more compact and competes with PFAS for the sites on GAC. While if your pH is around 7, then GAC is not as compact, and it basically does not compete with PFAS at the same level as at pH 5, which means that for particular separation process, pH 7 is preferable, especially when it comes to GAC in the presence of DOM. But it can again change if you think about some of the co-contaminants and phosphorus, carbonates, etc. And the second thing that what you saw on the PFAS oxidation part is that most of these catalytic processes or oxidation processes work better at acidic pH. So it really depends on which treatment you are doing, and that's why it requires research, because there is no blanket answer to say this pH is better for removal of the PFAS. It again depends on the water chemistry as well as what kind of treatments we are choosing. But that's why we do research.
Okay, and I think it's the last question here, and it's about making biochar via pyrolysis. And the question is a gas turbine power plant hot enough to aid in the pyrolysis process?
I don't know the temperature of gas turbine power plant, but I think that the temperatures we carry out pyrolysis is typically around 600, 700 degrees Celsius. So if the temperature is around that, yes, it can convert most of the organic material into the biochar, provided that there is absence of oxygen. So in the absence of oxygen, in that pyrolysis unit, you saw 600, 700 degrees Celsius is enough to convert the biomass into the biochar.
Okay, well, let's hear it for our panel.